You know, we've talked a lot about the caldera at Yellowstone. It erupts every 600,000 years. It's overdue. In a moment, Larry Mastin joins me again on Coast to Coast. We're going to talk about Yellowstone. And welcome back to Coast. I'm George Norrie. Larry Mastin back with us. And Larry, of course, is a hydrologist at the USGS Cascades Volcano Observatory in Vancouver, Washington. His particular area of interest is the physical process that controls the size, duration, and violence of volcanic eruptions. And let's check in with him on Yellowstone. Larry, I'm glad you're back with us.
Thanks, George. It's great to be here.
Okay, first of all, explain what a caldera is.
So a caldera is when you have very large eruptions. They're large enough that basically the magma chamber, which lies below the surface of the Earth, begins to collapse. So the roof of the magma chamber, which is the ground surface, starts to actually collapse into the magma body. And instead of having sort of a volcano, which you think of as normally a mountain, instead you have a giant hole in the ground. And so one example of that, if you've ever been to Crater Lake in Oregon, Crater Lake is a very large crater filled with a giant lake that formed about 8,800 years ago when a large eruption occurred and the caldera roof collapsed. But that eruption is probably 2 or 3 orders of magnitude smaller than the eruptions that occurred in Yellowstone in the last 2 million years. They've formed calderas that are 30 to 50 kilometers across. They cover most of the national park. Actually, is a caldera. So when you go to Yellowstone, you don't actually see a mountain, which is what you imagine when you think of volcanoes. You see what was a depression that's been mostly filled in by lava since the last major eruption about 600,000 years ago.
And with this prediction of 600,000 years ago of an eruption, we're past due now, aren't we?
Yeah, well, so there was a very large eruption about 2.1 million years ago. There was also a super eruption about 1.2 million years ago. So super eruption basically is the largest class of eruptions, explosive eruptions on Earth. They're eruptions that expel more than about 1,000 cubic kilometers of ash and tephra. And then the most recent of those super eruptions at Yellowstone was about 600,000 years ago. So there's been 3 in the past 2.1 million years. There's been an active discussion among people who study Yellowstone as to whether Yellowstone is capable of producing another super eruption. But there have been actually, Yellowstone lies at the northeastern end of a long chain of major volcanoes that have produced super eruptions for a period going back at least 15 million years. And so it seems likely that there will be more super eruptions in Yellowstone, but it's hard to say that it's overdue. It's not really periodic enough to say, okay, we should be having one any time. And if you look at the activity that's going on at the caldera right now in terms of seismic activity or uplift, it's basically doing what it's been doing for the last few decades. There's no suggestion that seismicity is ramping up or that the caldera floor is rising as you might expect right before a major eruption.
I was going to say, Larry, those are the telltale signs that you see. The floor starts to go up, up, and up.
Yeah, that's right. And, of course, when they started measuring the elevation of the caldera floor at Yellowstone, there were times when they started seeing it going up, but they also noticed after a few years it would start to go down again, and they realize now over the past 60 or 70 years since they've been measuring that the floor has been going up, and then it's been going down, and then it's been going up again. But we would probably expect it to go up way above any elevation that it's seen historically before we actually see a large eruption. So we continue monitoring it, but we haven't seen anything recently that suggests there's a big one that's about to happen.
Larry, in August, the USGS recorded 207 earthquakes out in that area. They had 99 in July. This increase, does that tell you anything?
Not really. The earthquakes there haven't been as large as you might expect before eruptive activity. So, for example, at Mount St. Helens in 1980, before the major eruption on May 18th, there were hundreds of earthquakes, all of which were large enough that you could feel them if you were within several kilometers of the volcano. There were earthquakes of magnitude 4 and even 5, and we would expect much larger earthquakes and more of them probably if it was really ramping up. And we'd probably expect to see it going on over a somewhat prolonged period of time, at least probably weeks or more.
Well, Larry, when we come back, I want you to give us that prediction. If it does go, what could happen? Because I've heard all kinds of horror stories. Plus, we'll open up the phone lines, give you an opportunity to talk with Larry Mastin. If you live in that greater area around Yellowstone, check in with us. If you just have a question, you're up too on Coast to Coast AM. Okay, welcome back to Coast. I'm George Norrie with Larry Mastin this hour and your phone calls. Larry, worst case scenario, the caldera blows its top. What happens?
So that's the question that we were trying to answer in the study that we just published. And in particular, what we were trying to answer was how much ash could people get? If you lived in New York City, could you get dusted by a meter of ash or a centimeter or a millimeter? Mm-hmm. And in order to answer that question, we had to develop a model that would actually put ash into the existing wind field. So we needed winds that transported ash around North America. So we used winds that were developed by NOAA for numerical weather prediction. And but we also found for an eruption that was this large, it would be putting so much ash into the air that it could actually drive ash upwind up to 1,000 or 1,500 kilometers.
Wow.
These big eruptions produce what they call an umbrella cloud. So if you're looking down at the eruption from a satellite, what you'll see is a circular cloud that's growing, and it's centered more or less right over the vent, or is being slightly displaced by wind as it's moving downwind. But that cloud can extend upwind quite a ways, and the implication of that is that places like in the Pacific Northwest, like Portland and Seattle, that are consistently upwind from Yellowstone, you would normally not expect to have much ash at all just from the existing wind field, but from a major umbrella cloud that would be produced during a super eruption, you could actually drive enough ash into those areas that you could produce over a centimeter of ash in some cases in Seattle or Portland. And so the results of the model are that most of the coastal cities, including the East Coast and the Gulf Coast and even the West Coast with the umbrella cloud, would probably receive millimeters of ash, in some cases centimeters. The Midwestern states would probably get up to a few centimeters. The Great Plains states, several centimeters, and of course, by the time you get up to the Northern Rocky Mountains, you could be tens of centimeters to over a meter in places like Billings.
So, and what kind of damage would that do, Larry? One, to health, and two, to wipe out crops and everything else, wouldn't it?
Yeah, so of course we're talking about very low probability events, something that has an annual probability of 1 in hundreds of thousands of occurring. But in places where they have where they've gotten ash from smaller eruptions, for example, you can have less than a millimeter of ash landing in certain places, and there's reduced visibility, there's reduced traction on roadways, there's frequently they'll close airports because of the lower visibility and the lower traction. People will have breathing problems. And once you start getting centimeters of ash or more, depending on the quality of construction in different areas, you can have problems with roof collapse. Over 10 centimeters of ash, you'll probably have roofs starting to collapse. And, of course, once you get tens of centimeters, you'll have major structural damage. And there will be other issues. Telecommunications will be probably dramatically affected. Probably the entire North America would air traffic would be shut down, and most a lot of surface traffic. So I mean, this is the largest class of eruptions on Earth, and of course there are going to be major effects from these, from an eruption of this size. We would survive. There would be probably major climatic effects as well, even smaller eruptions, but say bigger on the scale of eruptions of the 20th century, like Mount Pinatubo when it erupted in 1991 in the Philippines. Global temperatures dropped by about 1 degree Celsius for a few years, and people think that larger eruptions, well, in 1815 there was an eruption of Tambora volcano in Indonesia that significantly cooled the global climate. There were crop failures in distant parts of the world. There were parts of New England, for example, in the summer of 1816 that still had below freezing temperatures in June. And that was an eruption that was probably 100 times smaller than the Yellowstone eruption.
Well, when a caldera,
so there would be major effects.
Larry, when a caldera goes, is it just one huge eruption, or does it erupt for days, weeks, months? How long does it last?
Yeah, so that's, of course, we've never seen an eruption this size. So everything that has been inferred about how long these events last has been inferred from the geologic record. And there are people who've studied and looked at the deposits from Yellowstone and other large caldera-forming eruptions. There's one, for example, at Long Valley Caldera in eastern California that erupted about 700,000 years ago. And the people who've looked at the deposits from those think that the way they formed they think that they probably erupted over a period of days, maybe less than days. But there are a few other examples. The Aruanui eruption, which was in New Zealand about 26,000 years ago. It's the most recent super eruption in the world. There's evidence that it probably occurred in several steps that lasted months, if not a few years. So it may be very individualistic. One caldera will expel everything in a day, and another one might take months. But when we did our modeling, we did a series of simulations, the shortest of which was about 3 days and the longest of which was about a month, to try to consider all the possibilities.
How long does the ash stay on the ground? Does it dissipate when it rains? I mean, what are we going to do with it all?
Yeah, so, again, the experience we have for that comes mainly from more recent eruptions. But we know, for example, in 1980, when Mount St. Helens erupted, the ash that covered the ground surface, Mount St. Helens erupted in May, so it was early in the growing season in eastern Washington where they grow a lot of wheat. But it didn't seem to dramatically reduce crop production. In fact, in later years, it may have actually increased crop production. But there are, in other places, there's evidence, for example, in the Great Plains states, you can actually go out and see deposits from the Yellowstone eruptions in parts of Nebraska and Kansas. And the place where you can find deposits, they're actually very thick. They're, in some places, several feet thick, and they've been mined for abrasives because ash is very abrasive. It's been mined to use as polishing compounds. But we think that those deposits are not the original thickness. It probably, when it landed, it was thinner, but it was reworked by wind into probably dunes, and it was probably also reworked by water. And there are places, for example, in the Mississippi Delta where there are very thick deposits of Yellowstone ash that probably accumulated in the decades after one of the larger super eruptions and just formed part of the Delta deposit that now exists in the Mississippi River.
All right, let's go to some of the calls. East of the Rockies, Corey's with us. Alabama. Hi, Corey, go ahead.
Hey, Gary, I was wondering, are you guys, I grew up with you guys being around you and being survivalists. Yep. Do you prepare for being survivalists? And do you, Larry?
All right, Larry, what do you think? Do you prepare for the unexpected?
Yeah, our advice to everybody is that they should always prepare for emergencies. But on the other hand, if you were to rank the 10 or 100 most likely emergencies that you should probably prepare for, if you live anywhere in the country, even in the Great Plains states, a Yellowstone super eruption probably wouldn't be on that list because it's so infrequent. On the other hand, hurricanes and tornadoes and even eruptions from smaller volcanoes like Mount St. Helens are always a possibility. And so I live in the Pacific Northwest, and people in central and eastern Washington, many of them remember the eruption of Mount St. Helens, and still people would keep spare air filters for their cars available. Some of the municipalities would prepare for the possibility that another ash eruption would clog up their water mains, and they would have to clean those out. We deal a lot with emergency managers in the Pacific Northwest and advise them on how to prepare for ash eruptions. But again, Yellowstone, the last eruption of any kind, magmatic eruption at Yellowstone, was about 70,000 years ago, and it was a lava flow, a very large lava flow. Yeah, people should always be prepared for the possibility of a disaster, but a Yellowstone or super eruption is probably not the highest thing on the list that you should prepare for.
57 people died at Mount St. Helens when that blew up. If the caldera goes, though, Larry, 57 will be dwarfed by a big number, I'm afraid.
Yes, absolutely. There were, I think, hundreds who died at Mount Pinatubo in 1991, and there would have probably been thousands. The U.S. Geological Survey was working very closely with the Air Force at that time, which, of course, they had Clark Air Base right at the foot of Mount Pinatubo, and Mount Pinatubo was a volcano that hadn't erupted in centuries. So it surprised a lot of people when it started to come to life, but once the earthquake started and the geologists went there to look at the volcano, they realized when they saw the deposits that it didn't go very often, but it went big when it went. And so after about 2 months of precursory activity, they could see that every new step in the development sequence was bigger than the last one. And by about the 12th of June, 1991, they recommended that the Air Force evacuate Clark Air Base, and it turned out, fortunately for the USGS, that the big eruption happened just a few days later. We always have the concern that we'll advise people to evacuate, they'll evacuate, nothing will happen, and then we'll lose credibility and they'll move back, and something bad will happen after they move back. But volcanoes are never predictable.
Well, let me ask you, I mean, do you have forewarning at all? I mean, do you know definitively, even within an hour, it's going to blow?
Not usually within an hour, but we do know, I mean, there have been cases when we were actually able to see repeatable patterns. For example, when after the big eruption in 1980 at Mount St. Helens, there was a lava dome that grew in the crater over a period of about 6 years, and it grew sort of episodically. So there would be no growth for a period of several months, and then it would start to grow again for a period of a few weeks and then stop. And we would be able to see from the pattern of cracks that grew in the crater around the lava dome that it was close to erupting again, and we would actually be able to forecast within about 24 hours when the next eruption would start. But the thing about that was that these were very repeatable events, so we could see the pattern. And in many cases, what we're trying to forecast is a large climactic eruption that we haven't seen an eruption like that yet. So we're trying to see a pattern where there's no pattern that's established itself yet. But of course, we know that in most volcanoes will produce earthquakes before they erupt, and in most cases, those earthquakes will go on for days or sometimes weeks. If it's a volcano that hasn't erupted in a while, you need to spend some time cracking the rock to allow the magma to come to the surface before it actually erupts.
Let's go to Stephen, Scranton, Pennsylvania. Stephen, thanks for calling. Go ahead.
Hi, yeah. I heard about this a long time ago, and I've been trying to tell people about it. And I heard that it's 30,000 years overdue, and that if a potential eruption does happen, I heard that it could pretty much wipe out the entire world, and that the ashes would mix with the fluids in your lungs and pretty much turn into cement. Am I wrong on that?
Well, what do you think about? I don't think the people all around the planet will get wiped out, Larry. Those people in the region that get hit with that ash, it's not going to be a good thing for them.
Yeah, it's definitely not going to be good for them. There have been, so probably the biggest super eruption that anybody knows about was the eruption of Toba volcano about 75,000 years ago. And there's been a debate among archaeologists. Some archaeologists argue Toba volcano was in Indonesia, and so it would have impacted Asia quite heavily. And some archaeologists have argued that it reduced the population enough. They think that they saw some sort of reduction in the genetic pool for some period of time before the population was reestablished. But as far as I know, and I'm not a specialist on this, that evidence is still a matter of debate. But certainly it would impact the population of the United States if it happened. Again, this is a very low probability event, so it wouldn't kill off everybody on Earth. It's a matter of speculation how many people would die in North America, but certainly there would be very heavy impact in North America.
When Mount Vesuvius went in 79 AD that destroyed Pompeii, I assume they didn't have any warning at all, Larry. I mean, how much information do we have from the past?
I know that people felt earthquakes before the eruption of Mount Vesuvius, and even in Pompeii before. So there were two very discrete stages to that eruption, and the first one involved just ash falling on people who lived in Pompeii. So the ash falling didn't actually kill people, but the people who remained in Pompeii after several hours of ash fall were hit by pyroclastic flows and surges. So these were glowing avalanches of debris that were coming off the mountain and flowing right into the city. And so the people who are who that they have plaster casts of, for example, at Pompeii, were what they think were the stragglers who didn't leave the city during the early hours when the ashfall was heaviest. But yeah, there are times and places when eruptions occur with little warning. Maybe one of the best examples is the May 18th eruption of Mount St. Helens. There was months of increased seismicity and steam eruptions, but the morning of May 18th, the big eruption began with a major landslide that took off the north side of the mountain and turned into a lateral blast. And the lateral blast was what killed most of those 57 people who died in that eruption.
All right, Larry, thanks for the update. We'll keep checking in with you. You'll be one of our sources.